Hey guys, so we're going to do a quick review real quick over a topic that we learned earlier on in the year that instead of doing an assignment over, I want you to watch this video, okay? There may be a pop quiz about this particular topic next time I see you. All right then, so triangles and their angles. So one thing we learned about was that the interior angles of a triangle add up to equal 180 degrees. So for example, this was a equilateral triangle. All of these angles would add up to 180 degrees. Because 60 plus 60 plus 60 equals 180. Okay, let's say this was 40, 50, and this was 90. Well, all of these would add up to equal 180. But what if you had a missing angle? What would you do? So it said this is 40 degrees, this is 30 degrees, but I don't know what this angle is. What would I do? How would I figure it out? Well, if I know they all add up to equal 180 degrees, I know that 40 plus 30 plus this mysterious x will equal 180 degrees. Some of you already in your head, you're like, just add 40 and 30 and subtract it from 180. Absolutely. I'm just showing the algebraic reasoning behind that. So, if I want to figure out what x is, add 40 plus 30. And then subtract it from 180. That means that missing angle is 110 degrees. Now, remember, this only works for angles, okay? I saw some people on a different test, which was about Pythagorean theorem, and the side lengths of a triangle trying to use this 180 degrees. The side lengths have nothing to do with 180 degrees. Excuse the announcements. All right. Okay, so to figure out a missing angle, we would just add the two angles we know and then subtract it from 180. Okay, so there was another one, the triangle with the triangles is the exterior angle theorem. Okay, the exterior angle theorem states that the two angles that are non-adjacent, meaning not next to the outside angle, well, when you add them together, it would equal this outside angle. So, for example, if this was 40 and this was 20, and obviously this is not drawn to scale. If I know this one's 40 and 20, I know that this angle out here, this outside angle, the exterior angle of the triangle, would equal 40 plus 20, which is 60 degrees. Now, Ms. Patterson, what? And this is how I can prove that. Let's go again back to what we just learned about the interior angles. The interior angles say that the interior angles add up to give me 180. So let's ignore this outside angle and worry about this angle C. Well, 40 plus 20 plus x should equal 180, right? 40 plus 20 is 60. And if I subtract 60 from both sides, that would give me 120. So that means this angle right here, angle C, is 120 degrees. Well, what are these two angles making together? This interior angle C plus this interior angle D. They're making a straight line or a semicircle. And what do you know about that? That angle right here is 180 degrees or supplementary. So the angle C plus angle D should equal 180 degrees. So you could go the long way, find the interior angle, and then to find that outside angle, subtract it from the adjacent interior angle, and you would also get 60 degrees. So there's your proof that angle A plus angle B, the non-adjacent angles to this exterior angle would add up to equal it. All right. Moving on to parallel lines and their transversals. Okay, you're probably like, what? A numerator? What? Okay. Parallel lines and their transversals. When you have two parallel lines and draw a line through its area, it's going to create angles. You know, 1, 2, 3, 4, 5, 6, 7, 8 angles it creates. Well, when it creates these angles, it creates some angles that are congruent with one another, meaning equal, equivalent, same. And then it creates some angles that are supplementary, meaning they add up to 180 degrees. So, you have a couple of types of angles. Corresponding angles. These are the angles that are on the same side of the transversal. The transversal is this line right here. My two parallel lines are right here, A and B. So they lie on the same side of the transversal. So that means they're either both on the left or both on the right. And they're on the same side of lines A and B, either on top or on bottom. So if you notice, angle 1 and angle 5 are both on the left side of the transversal and on top of lines A and B. These would be called corresponding angles. Well, what do we know about corresponding angles? They are congruent. Angle 2 and angle 6, they are both to the right of the transversal and on top of lines A and B, and these are congruent angles. Angles 3 and angle 7, they are both on the left, to the left of the transversal and on the bottom of lines A and B, and these are corresponding angles. 4 and 8, they are on the bottom of lines A and B and to the right of the transversal. Those are corresponding angles. So if angle 4 was 120 degrees, then I know angle 8 is also 120 degrees because they correspond and corresponding angles are congruent. If I knew that 1 was 60 degrees, I also know that 5. Sorry, that wouldn't make any sense. Let's do 3. If I knew that 3 was 60 degrees, I also know that 7 is also 60 degrees because these are corresponding angles. The other type of angles, alternate interior angles. These are non-adjacent, meaning not next to each other. Angles that lie on opposite sides of the transversal. So remember, this is my transversal. These are the parallel lines A and B. And they're in the interior. Well, this is the interior in between lines A and B. So that would be angle 3 and angle 6. This is on the left, this is on the right, and they're both in the interior. What you need to know about these angles is that they are congruent. 4 and 5 are also alternate interior angles. So if angle 3 was 60 degrees, well, that means angle 6 is also 60 degrees. If angle 4 is 120 degrees, then angle 5 is also 120 degrees. Alternate exterior angles. Alternate exterior angles. Same thing, except they're in the exterior. So these are on opposite sides of the transversal. They're in the exterior, so that's on the outside of lines A and B. And what you need to know about these angles is that they are also congruent, meaning the same. So if angle 1 was 120 degrees, angle 8 would also be 120 degrees because they're on the exterior, and this is on the left and this is on the right. If angle 2 is 60 degrees, then angle 7 would be 60 degrees. We have same side interior angles. These are on the same side. Oh, hold on. Yeah, everything looks good. Okay. So alternate exterior angles. Same side interior angles are on the same side of the transversal, so line T. So they're both either going to be on the left or both on the right. And they're between lines A and B. They're in the interior. So again, they're in the interior on the same side of the transversal. So that would include 3 and 5. They're both on the left and they're in the interior. And 4 and 6. They're both on the right and they're on the interior. What you need to know about these angles is that they're supplementary, meaning their angles would add up to equal 180. Meaning their angles would add up to equal 180. So if angle 3 was 60 degrees, that means angle 5 has to be 120 degrees because 120 plus 60 is 180. If angle 4 is 120 degrees, then that means angle 6 is 60 degrees. Notice I'm using the same numbers for a reason. Last type of angle is vertical angles. These are formed when two lines intersect and they're opposite of each other. So for example, 1 and 4 are vertical angles, 2 and 3, 5 and 8, 6 and 7. What you need to know about these is that they are congruent. So if angle 1 was 120 degrees, 4 is 120 degrees. If angle 6 was 60 degrees, then angle 7 is 60 degrees. All right. Awesome. Woohoo!